Hello everyone, myself Divya from a student of Gautami Institute of Technology and Management for Women. I'm, I'm thanking MST Technology for providing me a wonderful opportunity. So I completed my internship on IoT towards MST Technology. During this internship, I did a project on IoT based home automation solution. And I want to thank Mrs. Jayalakshmi ma'am for providing a guidance throughout this internship. Now I am going to present on this project that what I learned during this internship program. Going to next slide. These are the content that I learned in this internship, that is C programming, Internet of Things, embedded systems, microcontroller. And coming to that project, so I am going to explain these project related topics, that is overview of a project, objective of a project, and design elements and stimulation, and finally conclusion. So let us start the topic with C programming. It is a general purpose language, even though it is applied and used effectively in various specific domains. So let us see the structure of a simple C program. So each and every C program must and consists of these 6 files, that is file header, processor directive, the start of a program, comment, statement, program termination. So file header stores all the files with a specific name, and processor directive consists of a header files and start of a program. Whenever the system or computer sees that the main function, it starts the program. And based upon our requirements and our program specifications, we can write the statements according to that. And finally, the program termination. Let us move that to the next slide. These are the topics that I learned in C programming, that is data type modifier and qualifier, conditionals and loops, operators, arrays and pointers, function, storage classes, preprocessors. So as we all know that about these topics, preprocessor is nothing but it consists of a header files. Storage classes is nothing but it stores that data. And function. So function majorly write in different 4 ways. Arrays stores the data in sequence order, whereas pointers is the address of another variable. Operators, generally we have different types of operators like assignment operators, relationals, bitwise, as so on. Next, conditionals and loop. Under conditions we get if condition, if else condition, else conditions, like that, and loops. So while loop, do while loop, like that. And next, coming to that IoT. In this slide, I'm going to explain about the IoT. This is nothing but how IoT is going to change our world, and what are the major applications that IoT use in our daily life. So here the transportation, heavy machinery, utilities, logistics, healthcare, manufacturing, and TVs, wearables, phones, home monitoring, appliances, home automation. Actually, these are all the applications that we generally IoT used. So IoT is nothing but collective network of connected devices, technology that facilitate communication between devices over the internet. And let us discuss what are the applications and examples of these Internet of Things. Here are the some of applications that majorly used: automobile, manufacturing, logistic, and transport for business. And these are examples for IoT: wearable health monitors, smart cards, smart buildings, home automation. Let us discuss what is meant by embedded system. So as we all know that embedded system is the combination of both hardware and software which is designed to do a specific task. So this is a simple block diagram of embedded system. It consists of sensors, AD converter, processors, and ASICs, D2A converter, adductor, and memory. So as we are very familiar with sensors, are temperature sensors, LDR sensors, soil sensors, water sensors, and next, as the name indicates that it converts the analog signals to digital signals. And processor. So here processor is nothing but the processor signals, and the D2A converter is nothing but the digital signals are converted to analog signals, and memory, it stores the data. So let us discuss these each block in detail. Sensor. Sensor measures the physical quantity and converts it to an electrical signal which can be read by observer or by any electronic instrument. A to D converter. It converts the analog signal sent by the sensor into a digital signal. Processor. Processor processes the data to measure the output and store it to the memory. And D to A converter. It converts the digital data fed by the processor to analog data. So the final block is that attenuator. Compares the output given to the D2A converter to the actual expected output and stores the approved output. Here, let us go a brief introduction about embedded system now. A combination of a computer hardware and software design for a specific function. They are low cost, low power, consuming small computers embedded in other mechanical or electronic devices. Generally, they comprise a processor, power supply, memory, and communication ports. Let us discuss the applications and examples of embedded system. So majorly the embedded system is used in electronics, robotics, security systems, telecommunications, automotive industry, and medical field. Here are the examples of embedded system. So as we observe in our general life or daily life, um, washing machines, ACs, refrigerators, these are all used made up of embedded system. CAD scanners, implanted heart monitors, electric vehicles, household appliances. And as we all know that embedded system consists of three parts, that is microcontroller, microprocessor, and memory elements. So now let us discuss what is the microcontroller and what are the blocks that performs the microcontroller. So actually the microcontroller may perform ADC block and DAC block, timers, counters, pulse width modulation, processor, memory and output input ports, microprocessor versus microcontroller, RAM, ROM and its types. So as the name indicates, ADC block, it converts the analog to digital and DAC digital to analog. Timers used to time measure the time that output present, and counters. So counters used to count the number of times the signal is takes place, and pulse width modulation. So processor is used to process the data. Memory is to store the data. Input output ports to take the input and output elements. And the differences between the microprocessor and microcontroller. So finally the memory means RAM, ROM and its types. So from this slide I am going to explain what is the project and what is the overview of a project and major objective, like that. So overview. The project provides an IoT based home automation solution using Arduino UNO board in PIXSIM Lab Stimulator. Blink IoT mobile application is used to control the devices remotely. Control the signals, temperature of the home and inflow and outflow of water in the water tank. And these are all the objectives of IoT home automation based solution. It connects the home appliances to the PIXSIM Lab Simulator and integrate it with a Blink IoT app using Blink Cloud. Control lights, temperature of home along with the level of water tank using mobile app. Open notification about the status of home of the mobile phone. So major objective of that is that whenever any difficulty or any reverse action takes place, um, who install the Blink IoT app, they will get the notification about that difficulties. Next, why this home automation is important and how it came. So generally people always do not stay at home. This brings the problem of home appliances not being monitored. The solution for this problem comes out to be a home automation. Home automation enables people to control most of the devices remotely, such as volume of water present in the water tank, guardian lights, temperature of the home. So through this home automation we control all these three parts. So first of all, for this we need to install a blank app in our mobile phone. After that we need to connect the code and dump your code to Pixum Lab, and finally it is connected to our home. And in this project we are using Arduino UNO board. So it is a microcontroller based board on the 80 mega 328P. It has 14 digital pins and analog pins, and at the same time it consists of a USB connection to code the code, to dump the code, and finally it consists of a one reset button to reset the pulse, and it can be programmed using different IDE, Arduino IDE. IDE is nothing but integrated development environment. So actually this Arduino IDE supports both C and C++ language. So the third step in this home automation is that Pixum Lab. So Pixum Lab is an open source real-time emulator of development boards with integrated MPLAB X debugger. It supports some Pixum microcontrollers and some SimWare microcontrollers. It has integration with the Arduino IDE for programming the board's microcontrollers. So as the Arduino board, it consists of a file, board, microcontrollers, modules, tools, help. So from this file we can upload the file whatever we want, and from the board we can select that whatever the board we want, and controller, and the type of the controller we can choose. From spare parts we can choose what are the parts that Pixum Lab consists of. Next, Blink IoT app configuration. So this is the first step in that home automation. So for that we need to how to install the app and what is the configuration of that app, and how to create new templates, how to add a device, how to select and add data stream, how to create icon, how to include blank library. This all come under the configuration. Next, light dependent resistor. Here if we observe here, dark detector LED. So it consists of one BJT, diode and photoresistor. So here for this resistor it has two pins, two port pins, and coming to graph, that resistance decreases with light intensity. We are taking resistance on y-axis and light intensity on x-axis. So this LDR sensor is a light detecting sensor that detects the light falls upon. The photoresistor is a light control variable resistor. The resistance of photoresistor decreases with increasing incident light intensity. The light LED are connected to the LDR via the ADC. It means that we can connect our LED lights to ADC or LDR. The ADC converts the analog input by LD into its equivalent digital form, which is then converted later by certain formula from 0 to 225 as upper bound. Based on that we glow the LED. So next coming to that guardian light control. The properties of LDR sensor is applied to accomplish the controlling of guardian lights. During that day, the outdoor light is maximum, so LDR sensor detects the lights and guardian light is turned off. Whereas at night, the outdoor light is very low, and so the LDR sensor detects the light and light is turned on. So actually what is the process under here is that the code which is we dumped in Arduino UNO makes to perform these operations. Whenever the at night games, this sensor is on and sends a notification to the mobile, and wherever the lights are on, and whenever that during daytime the sensors do not send any notification to the mobile and the lights are off. And next, temperature sensor. As name itself that this sensor is used to temperature. So majorly the temperature consists of a 3 port pins. The first pin is the voltage, and the second pin is the output, and third pin is the ground. Here we are considering LM35 temperature sensor. The temperature is recording using LM35 sensor, which reads analog value. The value is converted into binary value, and later actual temperature is calculated using offline value of a voltage. And the sensor does not require any external calibration or trimming to provide accuracies of plus or minus 0.5 degrees Celsius at room temperature, and plus or minus 1 degree over minus 50 degrees Celsius to 155 degrees Celsius temperature range. The output scale factor of LM35 is 10 millivolts per Celsius. For instance, it provides an output voltage of 250 millivolts at 25 degrees Celsius. Let us discuss the temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on the CLCD after converting it into a digital value using ADC. Control the temperature of a system by turning on off the heater and cooler to the Blink IoT mobile. From the figure we can understand that this is the app that we must install in our mobile, and finally we should install in our mobile. And next we need to connect this mobile is connected to that Arduino UNO, and the next Arduino UNO connected to that CLCD and temperature system. Whenever that mobile control and heater control and cooler control sends to that Arduino UNO, it sends to CLCD and temperature system. So whenever the temperature is too high, it sends a notification to the Arduino UNO, and it sends the notification to the Blink IoT app. This is the process under the temperature control system. And water tank inlet and outlet value control. So this figure is very similar to that temperature control system. So read the volume of water in the tank through serial communication and display it on the CLCD. Control the volume of water in the tank by controlling the inlet and outlet value by sending commands through serial communication, and display the volume of water in the tank on the CLCD, and also in Blank to IoT app. The tank refills itself when the outflow exceeds the threshold of minimum value 2000 liters, and it stops filling when the tank is full at 3000 liters. Gives notification to Blank to IoT app. So this is the stimulation image of before slides. So here this is LDR sensor, which is used to reduce and increase the temperature, and the values of temperature is noted in the display, and these are all the LEDs that use it to the LEDs on and off, and this is heater and cooler. So finally the project's conclusion is that, in the summary, the project provides a solution for monitoring and controlling home appliances and certain devices remotely. Using Blink IoT application and Pixim Lab Stimulator, home automation project is stimulator where LED temperature system, serial tank resembles light, heater, cooler, and water tank is real time. Blink IoT application allows user to control these devices according to user's wish, thus accomplishing home automation. So let us discuss